And it gives us a pair of key graphs that we should be able to reproduce anytime we asked, and they will be from our so-called library of graphs. I'm just trying to get to them. So where's the pictures they proudly produced for us? So it looks like here I see the graph of function cosine, and that's wave that will repeat itself to the left and to the right lots of times. So we get a something like that. And of course, it's not really the only portion, but there's more. But the key idea is it's in between of -1 and +1. And if I try to see so-called boundaries, or people say amplitude of this, then I can put this imaginary pieces, and well, just they indicate that we go to the left and to the right and always stay in between of these negative and positive ones. So that's our function cosine of x, of course. And we also observed the friend function, and that's what we worked with last time heavily. So that was also a wave that was in between 0 and 2 pi, but it had a similar shape, but it's a little bit different looking, and this is called sine function, right? Sine and cosine functions, they plot them by calculating various points, and that's exactly what they do here. So they put points, and then they make an observation that indeed these points seem to indeed compose the function that we call as a cosine, and analogous with a function that we call as a function sine of x. That's what I just opened here for you. And these two functions, one on the left and the other on the right, will be key functions for us throughout this class. So we're going to see a lot of sine and cosine and some other functions as well. We're already familiar with others, such as secant, cosecant, and tangent and cotangent. But at this stage, I just want you to only see those. Now, here's a very interesting observation they made. They noticed that if you look at both of these graphs and sine and cosine, then you can produce one by the other simply by shifting it by pi over 2. So if that's taking cosine function, which is here, and bringing it by pi over 2 to the right, so if I moved this whole picture by pi over 2, about as much as here, then the point that we have here would move to the origin, and that's going to give us exactly the picture that function sine has, and that's, I guess, what they say based on the pictures. And that's interesting observation to notice that actually both of these trig functions are very, very similar to each other. So in other words, you know how to deal with one in terms of graphing. The other will have analogous graphical ideas when you decide to produce its picture. And then the story started with various sine and cosine graphs, and that's what I'm going to do now. So I'm going to try to get to the section, and as usual, we're almost here. And in the skill building exercises, we're going to enjoy some of these graphings of functions. Maybe I can start with exercise number 19. It doesn't seem to look very attractive if you look at this equation a little closer, right? So let us do it. Exercise number 19. Again, the page, I prefer to use this number on the right side, or you can say it's a section 4 of chapter 6 if you like to call for a section. But I guess the key point is how to get faster to where you really need in the textbook, and that's why page number you can always type on the right side and get right into the page you need. So anyways, here's the equation. There is a 5/3 that is multiplied by my function sine. Last time we saw that this means it's amplitude of the function. And there's also some kind of -2 multiplied by pi over 3 with x. Okay. So what I'm going to do is imagine myself a graph of function sine, which is already here. And now I just need to decide what happens with the x, because in this case we have that -2 pi over 3 multiplied by x that needs to be placed in between of 0 and 2 pi. If you remember, the way to go was always the same. So we cared for the region from 0 to 2 pi, and that's how we would always start. So now I need to isolate letter x, and I don't need to have that negative fraction here. So what people do is they multiply by a reciprocal of it, which is -3 over 2 pi everywhere, and on the right, and on the left, and of course in the middle of this inequality. Well, multiplying in the middle of this inequality by this reciprocal is a key idea why we do this, so that my x will be cleared. So these two guys are going to cancel. So x will come out, and the key idea is, where is it varying? It looks like it be varying from 0. Now I should be a little bit more careful with inequality signs, right? Because I'm multiplying by negative. Remember, inequality always flips when you multiply by negative. Okay, so 0 is on one side, and on the other side will be a negative number what? Well, 2 pi's will go away, so it's just 3, right? Okay. So it looks like in between -3 and a 0 will be my wave for the sine. So if you look at again, that same basic wave that I have here, I have to put it in between -3 and 0. So, and of course, there is an amplitude of 5/3, right? 5/3. So put 5/3 here with a plus, and 5/3 on the bottom with a minus. So I have a graph. Like I say, so your graph is what? Still sine function, but the period of it has changed. People say it's in between 0 and -3, and if you decide to extend, the next will be 3, the next will be 3 plus 3 is 6, and so forth. So each wave is 3 units long, just like that. So looks like the graph does not really change its shape. What changes are the numbers on the top and the bottom. Those, instead of minus and +1, are now whatever is multiplied by the sine function. It happened to be 5/3. And also, instead of 2 pi, so-called period of functions, the length of that wave that repeats, is now equal to 3. So it doesn't matter to us. It could be just any number whatsoever. And keeping this in mind, I can try number 16. Now we're going to graph cosine for a change. So we added the story of cosines. And here, so let us take -3 cosine 3x and graph it. So now it's negative in front. Okay, so this means that our cosine function that we have here on the right side is going to be the one that actually starts at the point below and goes up above. So that's our wave. It used to start on the top, go down, and then return back. So that was a wave. Now it's reflected through x-axis. And that's really what it is, because of -3 being so-called amplitude. I say, so you put a -3 here. No, it's always plus -3. If it's a negative, the graph just has to be flipped. That's all it is. And now, in a search for a period, I need to put that 3x in between, as usual, 0 and 2 pi. It's always in between 0 and 2 pi. And I have to pull out x and, well, I guess just divide by 3, right? And you can see that x is in between 0 and 2 pi over 3. In other words, sometimes people say your period got 3 times smaller. And that's it. Yes, that's it. You can just put a few more wiggles if you want, but that's about it. So we got period that describes our stretch of graph from left to right, and the amplitude. That's the other characteristic that comes from -3, which is multiplied by that function. So the point of story, this is the same for all. And that's why all we need is to get used to this idea of simply taking a graph and either changing period or amplitude or both. And once it's done, then, well, then we're done. Besides this change in period, we also sometimes do a little bit of a shift of a graph up or down. If you remember with parabolas, we also did that before. So let me try, say, exercise number 49. It's the same story, but with a little extra. There is a -3 at the end, so we're gonna move this graph down. So let me first of all graph it without that -3. So I'm gonna do exact same thing we just did in the previous group of problems. So here's 5 cosine pi x. Okay, so I'm gonna deal with this new friend cosine function. So I already know the way my shape is gonna look like. It starts on the y-axis, sinks down and brings up. So it's always the same thing. But then we need to carefully mark the fact that we have amplitude equal to 5, right, because of that number with a cosine. And then we need to also see what's the period now. So I don't have to think too hard. I just put this pi x in between of 0 and 2 pi, always the same. And then isolate x, so I just need to divide by pi, right? Divide all of them by pi, so the left side is going to be 0, and we found x, that's what we needed, and it's 2 on the other side, so it's 2. We're not done yet, because we're supposed to actually graph with -3, so I have to bring this whole picture down, right? So let me graph this separately, and now it looks like we'll be at point 2 on the top. So let me write this again. 5 cosines of that pi x and then -3. So if we shift it down, then The lower one will be 5 and 3, which is -8, right? And other than that, the graph is going to be pretty much the same. So it still starts here at the y-axis and still returns back to the same level, and it's bounded from 0 to 2, right? That's what we just figured out. And that's all. You could, as usual, and it's a nice style, of course, to put this little extra like that and like that. And we're done. So same old stuff, but we could also move these pictures up or down if something is added or subtracted to the whole thing. Do one more of this. So the goal is to show you the problems are really all the same. Doesn't really matter what numbers involved in producing those. So let me do 51, not a recommended exercise. So again, I'm gonna just ignore 4 for the first step. So it'd be, I think, more straightforward for me to graph function sine, which is gonna now go not up but down, because for the positive function sine, we have to start at the origin, go up, and this is -6. So we start at the origin, we'll go down, and then return back, and then end at the same level. So this shape was flipped simply because of -6 multiplied. So we're still in between negative and a +6, but the graph was flipped again because we're graphing here -6 times function sine of pi over 3x. Okay, so next will be to take this pi over 3x and bound it in between 0 and 2 pi. See, I made it to be very standard, otherwise you might start struggling a little bit with various little obstacles if you decide to see how book proposes to do this exercise, then you will see that. But it's up to you. Whichever way you like to do problems is fine with me, because the end result is always the same. So I'm multiplying by a reciprocal of pi over 3, which is 3 over pi, because my goal is to pull out clean letter x, and that's what I just did. So on the left side, it's always going to be 0, because 0 times any number is 0. And on the right side is 6. So I did all that to put this number here, 6. So we know the period, it is 6. So the piece, periodic piece, repeats periodically. So not surprising. And then I need to bring this upwards by 4 units. So the whole picture has to go up 4 units from level of -6 to the level of -2, looks like, right? And from level of 6 upwards to the level of 10. So let me finish up with this graphing then. So now I know there is a -2 for the lower border and +10 for the upper border. So somewhere in between we start, go down, return back, and then go back to the same level somewhere. And this level of 0.6. So once you finished up with this approximate graphing, then you can repeat it a couple of more times. The thing is that the key number.
Professor, why did you go up 4?
Why? I don't know why, because they put it here.
Oh,
Yeah,
oh
why?
no, sorry. I thought you wrote out the question, so I didn't see the +4.
Yeah, I just follow directly the numbers they give us. It's just random numbers, and that's a good question to ask. Why 4? Why not 3? Some people like 3.5, but no, I understand it. So we have that given exercise, and whatever they add, we move it up. If they subtract that number, we bring it down. And I guess that's pretty much all this section says has for us. And also, even though the exercises to some people may look scary, if you look at them and say, oh, they look scary. But they're not scary. They're good little exercises because it actually doesn't matter to us what numbers you're gonna utilize for, I guess, graphing these functions. All we need to know is what is sine, what is cosine graph, and then we start to either bring them up or down or squeeze them. But I try not to squeeze them. I try to just tell what period is, because otherwise, if you go through these squeezes, that's a little bit tricky to graph. Because they all look like sines or cosines. So anyways, here they have a bunch of graphs already produced for us in the exercises. So in this group, they say match function with a graph. So what they want? Well, match the given function with a graph. Let's say if you look at exercise 21, for example, then you're gonna need to have the graph of function sine. So I already know the way sine looks like, right? Like that. And it starts at 0, and the question is, where does it end? It looks like it has to end wherever this pi over 2 x is allowing, right? So what I do is I put it in between 0 and 2 pi, and the goal is to pull clean letter x, just like we already numerously did here. So you have to take a reciprocal of pi over 2, so use 2 over pi. So it times by 2 over pi, left, right, so everything by 2 over pi. And this way the pi's will disappear, so we're gonna end up with x as being compared with 4. I say, what about 1 inside? You want to create more mess? Well, create with 2 over pi here and cancel. And the point is that if we have inequality, then you can multiply each entry of your inequality by same number, which is 2 over pi. And the key part, you got 4. That's why I did it. So now, as usual, we're in between -1 and +1 because there is nothing multiplied by, oh, actually not. I should have to be careful. It's 2 here. So it's actually from -2 to +2, right? Need to watch out. Don't want to relax. Let me write this function again, negative sine. That's actually positive sine multiplied by 2, pi over 2x. So we got this graph in here. So the question is, where do you see it on the picture? Is it here? No, because it has to start at 0, right? So where's the one that deals with this amplitude of stool, but starts at the 0 at the origin? Do you see one here? I think so, right? That's the one. So how can I say what the answer is? Well, here's the letter F. So for 21, we have letter F. So this is a perfect exercise for a quiz. So you don't have to graph anything, but just to tell Alex letter F is for the graph. How about if you tell me for the quiz, what be the letter with a graph for exercise 22? I think it's pretty much same as I just tried to select. So 22 will be our little quiz for today. So again, the question is, match the function. It's already given. So is it A, B? Definitely not F. F is already taken, right? So which letter do you think corresponds to the graph of this function? And give it a time. Don't hurry.